Okay everyone, let's go ahead and start with an introduction to functions, relations, notation, and sets. When we go ahead and take a look at graphing an equation, say for example y is equal to x squared minus 1. If you didn't know what it was, what would you do? Well, the first thing that you would do is most likely create a table of values. Now, how did you create a table of values? Well, we know that we have two variables here, x and y. So I'll put x and y. Here's my Cartesian coordinate system. So the horizontal axis is x, vertical axis is y. And I usually went ahead and substituted in values for x into this equation here to then come out with values of y. Then what I would do is I would take 0, negative 1, plot it, 1, 0, plot it, plot it, plot it. And being that I know that this is going to be a quadratic function, I'll just go ahead and connect it so that we know that it looks, so that the shape is that of a parabola. Now, a couple of very important things to recognize and important terminologies to know with regards to what we've just shown is that this horizontal axis is always going to be the values of the independent variable. Okay, so that's why I put the independent there. And any of the values that are generated here for the y values, any value that is associated with this vertical axis are going to be called values of the dependent variable. Okay, so we have independent and dependent. So what basically we can go ahead and think about is that all of these values of the dependent variable are all dependent on the values of the x value, which are all the independent variables, because you can choose whichever one you want. So, a couple of things that we want to go ahead and take a look at then is that if we go ahead and collectively put together all of these independent values, what they're going to create then is they're going to become a set of numbers. In the same respect, if we take a look at all the values of the dependent variable, those are also going to be considered a set because that, again, is just a collection of values. So what happens then is that all of these values of the independent variable, they are all going to collectively make up what is called the domain. And then the domain, and then all the values of the dependent variable are going to be collectively called the range. So basically what happens then is that if we go ahead and think about this, you pick a value from the domain, or an x value, an independent variable value, you substitute it into your equation, and what comes out is going to be a range value. So that's the relationship here that we come across with regards to actually graphing an equation. Okay? Now, being that we're talking about the domain and the range, what could those possibly be? Here are some typical sets for the domain and range. You have your natural numbers, which is symbolized by capital N, which is going to be like 1, 2, 3, 4, 5, and all your counting numbers. Integers, which is going to be your counting numbers, plus 0, plus all the negative counting numbers. Say, for example, if you wanted to talk about just the positive integers, you could use Z plus. Rational numbers, Q for quotient. Irrational numbers, Q prime, in other words, everything that is outside the rational set. And you have the last one, which is called the real numbers, which is going to look like an R with an extra line to the left of it. So it looks like an IR, but it really is an R with two vertical lines. And then there's also these other types of set notation and interval notation that we'll deal with in class. It's going to take a little bit more time, so we'll deal with that in class. Now, let's go ahead and just play with the idea of domain and range just a little bit more. If we were to go ahead and play with this here, what I could say then is that the domain for this, being that I'm collectively looking now at all of the values of the independent variable, I can choose any value that I want. So I can just say that that x is an element of the real numbers, or in other words, I can choose any value of the independent variable from anywhere on this line, any number that I wanted to choose. Now, if I go ahead and take a look at the range is going to be all the y values that are in this set here that is described by this graph, or also shown by this table, but incomplete by that table. And we know that all the range values are going to be y is greater than -1, greater than or equal to -1. Okay, let's go ahead and play with this, and let's change this, and let's see what you come up with. What if I was to go ahead and eliminate those two errors, and just say that this is what the function looks like? What is the domain for that? Obviously, the domain is not going to be all real numbers now. The domain is going to be -2 is less than or equal to x is less than or equal to 2, because all of the values for x, for this particular function, is between 2 and -2, including those endpoints. And then now with the range, well, the lowest value is still -1, but the y value, maximum y value, is actually going to be at 3. Okay, let's just do one last adjustment, and let's see if you can think about what would happen. What if I did this? If I did that, what does that mean? That actually means that the point 2, 3 does not belong as part of a coordinate of this graph. So what that means then is that the domain does not include 2, but does the range still include 3? And the answer is yes, because it is included on that side. So what we're going to need to be able to do as well is taking a look at a graph. Can you determine what the domain and range are? Okay, we'll go ahead and take a look at a couple more examples in class as well. Now, let's go back to this whole thing about the definitions of what a function and a relation are, because we haven't yet dealt with that. I called this right over here an equation before, and I showed how we actually started off with a deep independent variable value substituted into the equation to come up with a y value, which would then be part of the range or a value of the dependent variable. Now, this is what a relation is. It says any set of points on the coordinate plane. Anytime that you actually have a relationship between x's and y's, or the independent and dependent variable, you basically have a relation. And that relation then will create some kind of graph, and therefore you have any set of points on the Cartesian plane. A function, on the other hand, is a little bit different. It's more specific. It says a function is still a relation, because of course we still have to have some kind of relationship between the independent and the dependent variable, but in addition to that, it has to have every independent variable being paired with exactly one dependent value. So in other words, the question is if I put in a value of x, will I ever come up with more than one value of y? And for this situation here, y is equal to x squared minus 1, you can choose whatever value you want for x. You will always come up with only one value of y. And therefore, we can call this a function. And if you call it a function, you can actually use what is called the function notation. So I can say f of x is equal to x squared minus 1, or I can actually use this notation as well to represent the function. Okay, so to just summarize here then, when we take a look at the whole definition between relations and functions, relations are going to be the general, large or overreaching relationship between the independent and the dependent variable. And then within those relations, you're going to have functions, which actually have this extra property, that if I put in a particular value of x into the function, then I'm only going to come up with one value for y, the functional value itself. Okay, the last thing that I do want to go ahead and say then is that the most important thing is that you understand the relationship between the domain, the function, or the relation, the range, and how to actually go ahead and describe what the domain and range are. Okay, so we'll go ahead and take a look a little bit more in depth in class. That was quite a bit to take in, but give it your best shot, and hopefully that made sense to all of you. I'll see you next time. Bye-bye.